Okay, so we'll start going through JavaScript here. We're going to go through week 2 in JavaScript. This is week 6 overall in the Code Bootcamp, and this is the second pass at JavaScript. All right, so knowledge is power, information is liberty, education is the premise of progress in every society and every family. We're going to get into ECMAScript, and we want to understand. So here we can see all the issues that we just went through. And this has like everything from my sprint. However, the one that you're going to have access to is going to be the Clubhouse Code Bootcamp, and the type of issue is going to be any of these issues that we've created, and then we want to look at the ones that are done. And if we go to done, you can see the issue that's been completed. So if I slide this over here, you can see that we've added a definition for polymorphism. Right? Polymorphism is all described here. Polymorphism is the ability to write a single function that handles data types. It is a fundamental form of abstraction. Classic examples that you have an animal, and from the animal you can create a dog or a cat from that. So how many people are actually going through and filling out the issues that we have in Jira? We go to this board for this week here. We can go to our backlog and go ahead and start this sprint. So how many people are actually answering these questions? My other question is, why aren't we answering them? Because we want to use this to discuss what we're doing, and it's going to help you build up the knowledge to do this, right?
I wish I answered them at the beginning of last week, because I spent a lot of time trying to research a lot of those definitions being asked for individually, piece by piece.
And that's going to benefit you in the future, because I'd love to know, when you went to the conference, were you able to speak the language of the people who were at that conference?
Yeah, I mean, there was, we pretty much attended 2 seminars. We cut the second day short because we were feeling well, but for the most part, when they were talking Java, I mean, how they were kind of going through this process made sense, and then they gave references to how it looked like in C++, and JavaScript is C++, so it was really interesting. It was fun.
Okay, cool. All right, yeah, so whatever we have left for this week's sprint, I encourage you to contribute to that discussion so we can keep growing that. Otherwise, we'll just get into JavaScript here. So, why do I care? Right? ECMAScript is a scripting language that forms a basis of JavaScript. What do I need? VS Code, Mozilla Developer Documentation, and W3 Schools. How do I do it? We want to take this example here, and we want to understand how to use an arrow function. Right? Here's an arrow function. We can see that with arrow functions, you don't have to
take the slides.
So the question is, why do I care? ECMAScript is a scripting language that forms the basis of JavaScript. What do I need? VS Code, Mozilla Developer Documentation, and W3 Schools. How do I do it? Well, we can use an example of arrow functions. So we want to take this example above and change it to an addition operation. With arrow functions, you don't have to type the function keyword or the return keyword or curly brackets. This is a function in and of itself. So we want to take this example and change it to an addition operation. Now I'll take a look at the solution. So it's pretty straightforward, right? We have this arrow operation. We can declare our function and our parameters here. We have x and y, and this arrow operation is calling this operation to add these two variables together, and then we get the output. When we get the output, the element under ID is changed, and it's 10, right? Okay. What about? What new features were introduced in ES6 that were not available in previous versions, ES5 and below? The keyword let and const, right? These two keywords allow us to set a variable. Let acts very much like var. It's defined within the scope of a block, and then const is read only. Take a look at ES6. So, what is ES6? All right. As we said, some of the new features in ES6 are the let keyword and the const keyword. We also have arrow functions, and we saw the example for that. There's the concept of map, sets, classes, promises, and symbols. Here's an example of let. In this case, we have a variable, and we're assigning it to the value of 10, and then here we let x equal 2. That changes it, updates the variable. We also have const. So here we have a variable of 10.
Sorry, no screen. I didn't want you to do it.
Okay. So here we have an example of let. Let is a keyword and allows you to declare a variable within a block scope. Here we have a variable x, and we're setting it to 10, and here we let x equal 10. This updates the variable. Then we have the JavaScript const keyword. This keyword allows you to declare a constant, a JavaScript variable with a constant value. And constants are similar to let values, except that the value cannot be changed. It's read only. Okay? Then we have the concept of template literals. Alright, template literals use backticks rather than quotes to define a string. In this case, we set the text to be equal to hello world, and we use the back quotes here instead of single quotes.
Still, it's const.
Here we use backticks, and this defines a string literal. Right, this is a literal example rather than a string. Using these backticks allows you to create template literals. This allows us to create interpolation. We can use the $ in curly braces to interpolate a variable within that string. In this case here, rather than just having first name as a string, what this is going to do is going to print out John, and it's going to print out Doe. Now we'll go over arrow functions. Arrow functions are a compact alternative to a traditional functional expression. It's limited and can be used in all situations. There are differences between arrow functions and traditional functions. Arrow functions don't have their own bindings to this or super and should not be used as methods. Arrow functions don't have access to the new target. Arrow functions aren't suitable for call, apply, and bind methods, which generally rely on establishing new scope. Here's an example, right? We have our materials, hydrogen, helium, lithium, beryllium, and then what we're doing is we're calling the map function on this, and then we're printing out the material.length. So the output of this is going to be 8, 6, 7, 9. 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6. If we run this, we get the output of the array 8, 6, 7, 9. Now we'll go over the REST operator. So REST parameter syntax follows a function to accept any indefinite number of arguments as an array. So here's our function. And these are the parameters that we're passing in here, right? So we run this, we'll get an output of 10, and then we'll get an output of 6. So the first one comes out to be 6, and then the second one comes out to be 10. Here is the example on rest parameters. The rest parameter syntax allows a function to accept any indefinite number of arguments. Here we have an example, right? We can take any indefinite number of arguments here, and this gives us an output. In the first case, it gives us 6, and the second case, it gives us 10. What we're doing is we're going through and we're adding the previous and the current value. Now we'll look at spread syntax. So spread syntax allows an iterable such as an array expression or string to be expanded in places where 0 or more arguments or elements for array literals are expected, or object expression to be expanded in places where 0 or more key value pairs for object literals are expected. Here's an example. We have a function that takes a sum, returns a sum. We're defining an array here, 1, 2, 3, and then we sum the numbers in this array. We call dot apply on that sum. Gives us 6 and 6. Right? We're adding up all the elements in this array. So 1 plus 2 plus 3 gives us 6. Alright, now we'll look at object destructuring. So the destructuring assignment syntax is a JavaScript expression that makes it possible to unpack values from arrays or properties from objects into distinct variables. Here's a simple demonstration. Here we're defining a set of variables, we're declaring them, and then here we're assigning them. So we're saying let A and B be equal to 10 and 20, and then we log out the output from A and B. The output is 10, 20. Here is a list of all of those variables being defined, and then we get our expected output array. We can run that. To go over this again, here is a simple demonstration of a destructuring assignment. We have a set of variables here at the top, and then we are going through and we are initializing each of these variables in an array, and we're printing out the output. Here we're defining even more variables in an array, and then we're printing out the output. If we run this, the first example we get 10, the second one we get 20, and then the full array is 30, 40, and 50. Right, that's how this works. Okay. Go ahead and check. Right. Now we'll look at the ternary operator. So the ternary operator is the only JavaScript operator that takes 3 operands. A conditional ternary operation checks to see if an expression is true or false. If it's truthy, it'll look at the values between the colon and it'll set the value to the right return type based on the validity of the Boolean expression. Here's an example. We're checking to see if a person is a member, and if they are, it'll be $2. If they aren't, it'll be $10. So here we're calling get fee, and then we get our result, right? So $2, $10 comes back to be $10. Now we'll go over JavaScript this. So, what is this? Let's take a look at this from CodePen. We want to try to understand what this is, and we can look at this specific set of JavaScript code here, right? Here we have an object that we're defining with a property and a value, and then we have another property with a key and a value of this. If we run through the code, we have a function here called myFunction, and we're logging out this. And we have another function which is set on a second object. We're calling myFunction.to, right? So this is just a way for us to refer to these functions. Alright. So if we go through each one of these, we define a function here, and this is a call to a window. Alright. So let's go ahead and run this. So here we're defining our object, right? And we have our set of functions and our properties. Keep going through this. There's more properties associated with this object. Get down to the next line in the code. Okay. And the key to this is to understand that this is really just a self-replicating reference. It's just referencing the object itself. This is a keyword for referencing itself. We'll take a look at a simpler example. This one is highly confusing, very complicated. It's something that you can look at. It's more advanced. We'll take a look at a simpler example. All right. So what is this? This is a self-reference to an object. It refers to an object that calls itself. All right. This can be a confusing topic. However, we can think of this as an intrinsic property on the object. And the new keyword ensures that this always points to the object that you create. We'll use that new keyword to instantiate a new object. All right. It can be used to call a method after we've created that object. We can call myObject.myMethod, and we can use it to access properties on that object. Let's take a look at the new keyword here. All right, so the new operator lets developers create an instance of a user-defined object type or one of the built-in object types that it has a constructor function. Here we have an example of an object, a car, which has a make, model, and year. And then we're passing the parameters into the constructor to initialize this object. And then we're calling console.log car.make. This is going to print out an eagle. Right? Since we're passing an eagle as the make, so this refers to the object itself. So the car has a property, make, model, and year. This attaches those properties to the object. Now we'll take a look at an arrow function. Arrow functions were introduced in ES6. Arrow functions allow us to write shorter function syntax. As we saw in the example, we can define a function that does multiplication without specifying a return. All right, now we'll look at call. Okay. So call is a method that returns a function with a given this value. Right? Here we have a function product, and we have this .name, this .price, which specifies the name on the object and specifies the price on the object. Then we have another object, food. And we're calling product.call. We're passing in this parameter, which refers to the object food, name, and price. And then this has an additional property called category. So when we call food here, we are now passing in cheese 5.name. Right? We're making a new call to the name property on here. What this is going to do is it's going to go to food, and then it's going to go up to the product and up to the name. It's going to print out the name cheese. Okay?
So if you remove the dot and the name, it would give you the whole array.
Yeah, I think that'd be a good exercise to try. Here we go. All right. The bind method creates a new function that, when called, has this keyword set to the provided value with a given sequence of arguments preceding any provided when the new function is called. Here's an example of bind. In this case, we have a property of x and a getter or getX. What this will do is it'll return that property x. All right, so here's the console.log get unbound x, and here the function gets invoked at the global scope, and the expected output should be undefined. We have another example here, unbound get x.bind module, and the output is going to be 42. Now look at apply. So the apply method calls a function with a given this value and arguments provided as an array or an array-like object. Here's a set of numbers, and then here we're calling math.maxApply, so we're fetching the largest number from there. And this back to be 7 and 2. Okay. And now we'll look at apply. So the apply method calls a function with a given this value and arguments provided as an array or an array-like object. Here's apply. Okay. We are calling apply on this array of numbers here, and then we're calling the min, so fetching the min and the max. When we do that, we get 7 and 2. Okay. Yep. And there are more examples in this documentation, so you want to understand how to go through and use the apply operation here. All right, so why do I care? This refers to an object. What do I need? VS Code, Mozilla developer documentation, and W3 schools. How do I do it? Take the example shown above and change it to print out the sum of 42 and 20. Now you give it a shot. Okay. Yeah. So I went ahead one way of doing it, right? Here's the solution. This is the solution of the problem. We just add this to the property here, and we get the output. And we can see that this is the keyword that's referring to this property here. So whenever we do that, it actually refers to this property. All right, what about? Why do we use this keyword? The most common use of this keyword is to eliminate the confusion between class attributes and parameters with the same name, because a class attribute is shadowed by a method or constructor parameter. Now we'll go over JavaScript object-oriented programming. So object-oriented programming is one of many programming paradigms and is probably the most popular. ES6 syntax is the old means of doing it, so we don't really use it too much. And classes, in this case, are always going to begin with a capital letter. We'll take a look at the class keyword, the constructor function, and instantiation and static methods. Okay, here is JavaScript object-oriented programming. Object-oriented programming is a programming paradigm fundamental to many programming languages, including Java, C++. So we'll go over the concepts of object-oriented programming and then describe the three main concepts of classes, instances, and inheritance and encapsulation. All right, so inheritance. Who can tell me what inheritance is from their understanding?
Property that gets passed down.
It's a class created with inheritance, inherits all the methods from another class. All right? And object-oriented programming is about modeling a system as a collection of objects, where each one represents some particular aspect of the system. Okay, so object-oriented programming is a paradigm fundamental to languages like JavaScript, Java, and C++. We have the idea of a class and an instance, right? In object-oriented programming, when we model a problem in terms of objects, we create abstract definitions representing the types of objects we want to have in our system. So for example, if we're modeling a school, we might have objects representing professors. Every professor has some properties in common. They all have a name and a subject that they teach. Also, every professor can do certain things. For example, they can all grade a paper. They can introduce themselves to their students. So a professor could be a class in this system. Here's an example of the definition of a class for the professor, and then we have properties, name, and teachers. Okay. We have class, professors, properties, name, teaches, methods, grade, introduces self. All right, now we'll take a look at the class keyword. All right, so the syntax for this, right, we can use the keyword class to create a class. We always want to add a method named constructor here. This constructor is what creates the object. So here we have the class car, and the constructor takes in the name and the year. This .name is being assigned to the name, and this .year is being assigned to the year. The example above creates a class named car. The class has two initial properties, name and year. Now look at constructor function. So the constructor method is a special method of a class for creating and initializing an object instance of that class. Here's an example. We have a class polygon with constructor, and it takes this .name and sets the polygon value to that. And here we have a constant polygon. We're instantiating a new polygon, and we're logging out polygon.name. And this gives us the expected output. And if we run that, here's polygon. Now we'll take a look at static methods. So static methods are defined on the class itself. You cannot call a static method an object, only on an object class. Here's an example. We have a class car with a constructor, and we're setting the name value here to be the parameter passed into the constructor. And then we have a method hello on here. When we instantiate a new instance of this object, we pass in the name. When we pass in the name, it sets the property in the object, and then we call the method hello, which will print out hello. Object-oriented programming. Why do I care? We can use object-oriented programming to simulate real-world objects. What do I need? VS Code, Mozilla developer documentation, and free code camp. How do I do it? We'll take this example here, JavaScript class inheritance, and we want to take the example shown above and add a new property to show the style of the car. So we have a car here, a constructor, and then we have a method. So continuation of this is the model, which extends car, and then we have a constructor, and we call the super method here, which goes up to the parent, and it will pass in the brand, and this has a method show associated with it. Okay, now you give it a shot. We'll go through the solution here. All right, we have this example of inheritance, and we can go ahead and understand it from this example here. How do I do it? Right, we have our car here, and then we add this style attribute on the car, and this is actually what Riley did, right? So the goal was to just pass this into the car being called here in the super. Were you able to do that, Riley? Did you update the constructor?
No.
Yeah, that's the key here, because what happens is this property is on the car. When we create a model, we need to pass that style into the constructor super method, which then will add that property to the car object, right? And then when we go through and run this, it'll actually print out all of the properties in the correct order. Okay. All right, we'll take a break here. All right, as we saw, this is a way that we can go through and add a property and update the constructor. So what if, what about? Object-oriented programming is famous because it implements the real-world entities like objects, hiding, inheritance, etc. So, we'll go over inheritance. Inheritance is when one subclass of another is created. For example, Ford and Chevy are subclasses of car. We can use the extends keyword to make these connections. We can use the super in our constructor to save some time. I can go up and call the parent class. And then we can call static methods from the parent class from static methods in our subclass with the super.method. Let's take a look at inheritance. So here's JavaScript inheritance, right? To create a class, use the extends keyword. A class created with a class inheritance inherits all the methods from another class. Create a class named model, which will inherit the methods from the car class. Here we have the car class, a constructor, and then we are calling the method present. So present will print out I have this car name. This car name refers to the property on the car. Model extends car. It has a constructor which takes in brand and model. And we call super, that goes up to the car and it passes in the brand, and then we call this.model. We can show this using the show method. So let my car equal new model Ford Mustang, and then here's the call to it, right? We have mycar.show. Now we'll go through extends. The extends keyword is used in class declarations or class expressions to create a class that is a child of another class. Here's a demonstration. We have a class date formatter which extends date. Okay, and then we have a set of months which are associated with that. And then we're returning a template literal that uses the variables from the class. So this.getDate, this.getMonth, this.getFull year. All these properties are being used here. You can run this, and it gives us the date as a string. The example that we have here, we're looking at a date formatter, and it extends the date. So get formatted date, and we set up a set of months in the array, and then we return the template literal string here. And we can log out a date formatter here, the object, .get formatted date. So get formatted date is going to show us the formatted date. When we run that, we get 19 August 1975, since that's what we pass into the constructor of the date formatter. Now we'll look at super. Super keyword is used to access and call functions on an object's parent. The super.prop and the super expressions are valid in any method definition in both classes and object literals. So here's super, and it takes in the arguments. Super.function on parent takes the arguments here. So when used in a constructor, the super keyword appears alone and must be used before this keyword is used. The super keyword can also be used to call functions on a parent object. Here's an example of using the super in classes. This code snippet is taken from the classes sample. Here, super is called to avoid duplicating the constructor parts that are common between rectangle and square. We don't want to keep those commonalities here. So super takes in length and length. And then if we go up here, we have our constructor, height and width, right? Those are what are being passed into this as properties. So why do I care? Inheritance allows you to reuse properties and methods of an existing class when you create a new class. What do I need? VS Code, Mozilla Developer Tools, and W3 Schools. All right. Let's look at the example that we just saw. Here we have a car object and we have a model that is being extended from the car. And what we want to do is, again, let's create another object that can be inherited from the car. So can you think of an example other than a model that could be extended from the car? Okay, that isn't really how we want to do this, so we'll go ahead and we'll look at an example here and we'll make this into a module. Alright, so everyone should be able to see my screen here in just a second. Let me get this put up here. Just want to make sure we got this all situated nicely here. Alright, so everyone can see my screen now, right? Alright, now we have an example where we can look at JavaScript inheritance. So we use the extends keyword to inherit all methods from another class. And we use the super method to call the parent's constructor function. In this example, we have an object car. From car, we create a object called model. And then we also have another object here called style. So what we can do is we can create multiple objects off of this car, and they're inheriting it. All we have to do is reference the car constructor as super, and we can pull in those properties into these objects. Right? So we have an example here where we have a car, and then we can create a style which extends car. It might better actually change this to a type. Change it to a type there. Now we have a type. We can open this in our Explorer here, Review and Finder. And then this is the module that we want to go to. And this is the example that we have. This uses the extends keyword to inherit all methods from another class. It uses the super method to call the parent's constructor function. And then we have I have a Ford. It is a Mustang. I have a Ford. It is a sports car. Go back here. So I have a Ford. It is a sports car. Right, we're doing myType.show. So myCar.show and myType.show. Each one has a distinct method associated with it. You see that? Show and show. Okay. So when would I use inheritance? The main reason for using inheritance is not as a form of composition, it is that you can get polymorphic behavior. Now look at asynchronous JavaScript. What is asynchronous JavaScript? Synchronous programming is what we've been doing thus far. JavaScript reads and executes application from top to bottom, left to right. Asynchronous programming is the opposite of this. It is a cornerstone of how Node.js works, so it will be important moving forward. Next to understanding this, async is probably the second most difficult thing about JavaScript. We've already seen callbacks a little bit, but here we'll take a deeper dive into the problem of using asynchronous programming. Callback hell is when you have too many callbacks being processed at the same time. It's too difficult to understand where the callbacks actually end. And to simplify callback hell, ES6 introduced promises. Promises are kind of like functions that are asynchronous. The promise constructor takes in two parameters. The first is a resolve and the second is a reject. When you call resolve, that activates the .then side, and reject calls the .catch side. We can chain promises together, and we can return promises from other functions. Let's take a look at what asynchronous actually means. So, asynchronous programming is a technique that enables your program to start a potentially long-running task, and then, rather than having to wait until that task is finished to be able to be responsive to other events while the task runs, once the task is completed, your program is presented with the result. Many functions provide browsers, and especially the most interesting ones, can take a potentially long time, and therefore asynchronous is valuable. For example, making HTTP requests with the fetch method, or accessing a user's camera or microphone using the get user media, or asking the user to select files for accessing through the system. We can use a file picker, right? Again, asynchronous programming is a technique that enables your program to start potentially long-running tasks, and then rather than having to wait until the task is finished to be able to continue to be responsive to other events while the task runs, once the task is completed, your program is presented with the result. Many functions provided by browsers, and especially the most interesting ones, can take a long time, and therefore asynchronous programming is being used. For example, making HTTP requests with the fetch method, or accessing the user's camera or microphone to get user media, or asking the user to select files for you to access using the show open file picker. So even though you may not have to implement your own asynchronous functions very often, you're very likely to need to use them correctly. In this article, we'll start by looking at the problem with long-running synchronous functions, which make asynchronous programming a necessity. So here's an example of synchronous programming, right? Everything's executed sequentially. We declare a string called name, and then declare another string called greeting that uses the name, and then we log the greeting to the JavaScript console. What we should note here is that the browser effectively steps through the program one line at a time in the order that we wrote it, and at each point it waits for the line to finish its work before going on to the next line. It has to do this because each line depends on the work that was done in preceding lines. That makes this a synchronous program. It would still be synchronous if we called out a separate function like this, right? Make greeting, and then this is still synchronous. A long-running synchronous function. What if the synchronous function takes a long time? The program generates a number of large prime numbers using a very inefficient algorithm. When the user clicks Generate Primes button, you can control the number of primes to generate, which of course affects how long the operation will take. Relatively long operation to go through here and calculate all the primes from this method, right? Here's the generate primes, and then here we have is prime. So we go through and we check to see if this is a prime number starting at 2, then going through and processing until this is less than or equal to the square root of the number, incrementing each time, right? And then as we do that, we create a new array, we set a maximum. And while this primes is less than the quota here, we will find the candidate for this and then check to see if it is prime. And if it is, push it to the candidate, and then we return primes. Here we can see that we're doing some processing on the HTML side. So we have the query selector, which selects the element by the ID generate and adds an event listener click, right? This event listener will then process the quota that's returned from there. We'll generate the primes and then return those as primes. And then once this is called here, it'll reload the page. So we can generate the number of primes here, So finish generating all of the primes. Let's just try and generate 10 primes. Okay. 100 primes. 1,000 primes. 10,000 primes. 100,000 primes. 1,000,000 primes. Now you can reload. See how that took longer? We didn't have to wait for the program to finish. Essentially, this just finishes using asynchronous programming. There we go. Right, that's the benefit, is this action is happening in the background without us having to, sequentially go through each step. Now we can look at callbacks. All right. I will call back later. Famous last words, right? A callback is a function passed as an argument to another function. This technique allows a function to call another function. A callback function can run after another function is finished. Here's the function sequence. JavaScript functions are executed in the sequence that they are called, not in the sequence that they are defined. In this example, we end up displaying goodbye. Right? Here we have my displayer, hello. We call it my first and my second. This example will end up displaying hello. Okay. Now we'll look at promises. The promise object represents the eventual completion or failure of an asynchronous operation and its resulting value. To learn about the way promises work and how you can use them, we advise you to read Using Promises first. A promise is a proxy for a value not necessarily known when the promise is created. It allows you to associate handlers with an asynchronous action's eventual success, which is a value or failure reason. This lets asynchronous methods return values like synchronous methods. Instead of immediately returning the final value, the asynchronous method returns a promise to supply the value at some point in the future. A promise is in one of these states, either pending, fulfilled, or rejected. A pending promise can either be fulfilled with a value or rejected with a reason, an error. When either of these options happen, the associated handlers queued up by a promise's then method are called. If the promise has already been fulfilled or rejected when corresponding handlers attached, the handler will be called. So there is no race condition between an asynchronous operation completing and its handlers being attached. As the promise.prototype.then and promise.prototype.catch shows here in this example, we have pending promise, which goes to being fulfilled or rejected. Then we check .then here. So in this case, if there's a catch, there's error handling, and then that goes back here after we've done the return, and we have .then and .catch. Okay. So a promise is said to be settled if it is either fulfilled or rejected, but not pending. You will also hear the term resolved used with promises. This means that the promise is settled or locked in to match the state of another promise. States and faiths contain more details about promises terminology. Now we'll look at async and weight. So an async function is a function declared with the async keyword, and the await keyword is permitted within it. The async and await keywords enable asynchronous promise-based behavior to be written in a cleaner style, avoiding the need to explicitly configure promise chains. Async functions may also be defined as expressions. Here we have a function, so resolve after 2 seconds, return a new promise, resolve. You want to set the timeout and resolve to resolved. Here's the async call, console.log calling, and then we're setting the result. So resolve after 2 seconds is being called with the await value here. So resolve after 2 seconds, and this will output resolved after we do the asynchronous call. We'll go ahead and run this example here. So it goes calling and then it goes resolved. There's a slight delay there. So, why do I care? Asynchronous programming is a technique that enables your program to start a potentially long-running task. Rather than having to wait until that task has finished to be able to continue to be responsive to other events while that task runs, once the task is completed, your program is presented with the result. What do you need to do this? VS Code, Mozilla Developer Tools. How do I do it? Take the example shown and modify it to take additional parameters. Set my calculator to take a third parameter. Now you try it. Alright, so we were asked to add a third parameter to that method which had a callback set up in it. Here we go. This is the solution. The requirement was to just add an argument, an extra argument that allowed us to calculate the sum for 3 parameters. So when we're working in industry, that's a key thing to pay attention to, is we didn't have to change that callback. That callback function was totally fine on its own. The purpose of that is to call the display, which will then set the value in there. So this will take the 3 numbers here. This is the third parameter that we added. We still have the callback. This callback gets passed to it, right? And what we're passing as the method is the myDisplayer method. So myDisplayer is the method that's being passed in as the callback. Once the sum is calculated, we then pass the sum into whatever method is the callback. You see the difference here. Awesome. Make sense? Cool. So when should I use asynchronous JavaScript? Asynchronous loops are necessary when there's a large number of iterations involved or when the operations within the loop are complex. But for simple tasks like iterating through a small array, there's no reason to overcomplicate things by using a complex recursive function. Now we'll touch on AJAX. So, what is AJAX? AJAX is a developer's dream because you can read data from a web server after the page is loaded. You can update a web page without reloading the page. You can send data to a web server in the background. Let's try an example. Here we have the Xml Http Request object. This is the single most important thing for you to pay attention to as a web developer. You need to eat, breathe, and sleep and understand what the XML HTTP request object is, because it is the fundamental building block of a request. This is so important. It is the most important thing. It is so important that everyone needs to say back to me right now, this is the most important thing that we're learning. Clear? Not AJAX, XML HTTP request object.
You can't see your page, your screen. Thank you.
Yep, this is very important. Why is this important, right? Here we're creating this new object, and then we have XHTTP onload, which loads in this function, right? Once this request is complete, this function is called and it shows the response. This is the way that a client can talk to a server. Okay, so the XML Http request object is the thing that goes in between the client and the server. This is the fundamental underpinning of web development right here. Okay, so when we go to click change content, everything on the page is changed. Right? This was the moment in the history of the internet when totally new businesses were created, right? Now we have the option to request objects from a server and use them on a client. We can update that client to show new content asynchronously, okay? So, in continuation. AJAX requests can be useful for using APIs, whether we've defined them or another developer did. We haven't learned how to build our own APIs yet, so we can see how to use someone else's API, right? The methods that you'll need to know are get, post, put, and delete. The statuses that you'll need to understand are 200, 400, 403, and 404. 200 means it's good, 400 means it's bad, 403 means it's forbidden, 404 means it's not found, 500 means it's a server error. Okay? And so a post method is writing data somewhere. A put method is updating data somewhere. A delete method is deleting data somewhere. Okay? So we'll look at a get method. The HTTP get method requests representation of the specified resource. Right? Requests using get should only be used to request data. They shouldn't include data. The HTTP get method requests a representation of the specified resources. Requests using get should only be used to request data. They shouldn't include data. Okay? Now we'll look at a post method. So the HTTP post method sends data to the server. The type of body of this request is indicated by the content type header. The difference between put and post is that put is idempotent. Calling it once or several times successfully has the same effect, that is, no side effect, where successive identical posts may have additional effects like passing in order several times. A post request is typically sent via HTML form and results in a change on the server. In this case, the content type is selected by putting the adequate string in the included type attribute of the form element or the form inc type. Okay. All right. So now we'll look at the put method. So the HTTP put method is a request to a new resource that replaces the representation of the target with the request payload. The difference between put and post is that put is idempotent, right? Calling it several times has no side effect, whereas successive identical post requests may have additional effects, akin to placing an order several times. Now look at the delete method. The HTTP delete requests method deletes the specified resource. Now look at our HTTP statuses. So the HTTP 200 OK success is a status response that indicates that the request has been successful. A 200 response is cacheable by default. The meaning of a success depends on the HTTP request method. Okay, so we looked at get, head, post, trace, right? The successful result of a put or delete is often not a 200 OK, but a 204 no content or 201 created when the resource is uploaded for the first time. Here's our status, 200 OK. Now we'll get a 403 request. So The 403 forbidden, right? The HTTP 403 forbidden response status code indicates that the server understands the request but refuses to authorize it. This status is similar to 401, but for the 403 forbidden status code, reauthenticating makes no difference. The access is permanently forbidden and tied to the application logic, such as insufficient rights to a resource. And now we'll look at a 404 not found. So the HTTP 404 not found response status code indicates that the server cannot find the requested resources. Links that lead to a 404 page are often called broken or dead links and can be subject to link rot. A 404 status code only indicates that the resource is missing, not whether the absence is temporary or permanent. If a resource is permanently removed, use the 410 gone status instead. Now we'll look at the 500 response code. So 500 internal server error, the hypertext transfer protocol, HTTP 500 internal server error response code indicates that the server encountered an unexpected condition that prevented it from fulfilling the request. This error response is a generic catch-all response. Usually this indicates the server cannot find a better 500 error code to response. Sometimes server administrators log error responses like 500 status code with more details about the request to prevent the error from happening again in the future. And this is the 500 internal server error code. So, why do I care? AJAX can be used for interactive communication with an XML file, the extensible markup language, a markup language similar to HTML but without predefined tags to use. With XML, you create your own tags instead. What do I need? VS Code and the W3C documentation. What's that? So why do I care? AJAX can be used for interactive communication with an XML file. XML, extensible markup language, is a markup language similar to HTML but without predefined tags to use. With XML, you create your own tags instead. What do I need? VS Code, W3C documentation, and how do I do it? So clone down the AJAX module that's been added to the GitHub repository. We're going to add a Git method.